Hey everybody, welcome back to the Speak Up for Blue podcast. I'm your host, Andrew Lewin. I hope you had a great week so far. It's Wednesday, it's Interview Wednesdays. And speaking of which, we have a great guest on today. We have David Johnston from the Duke Marine Laboratory in Beaufort, North Carolina. And he's from the Nicholas School of Environment. He also is the director of the Marine Robotics and Remote Sensing Group at the Nicholas School of Environment, and a fellow Canadian. I didn't realize that before we got on the show, and I did some research, but he's here to talk about how drones are used in marine conservation. It's kind of an interesting aspect because, up until, I don't know, even 10 years ago, drones usually had a negative connotation in terms of military use. Now it's got something positive, which is nice. We're using it for marine conservation, and we're going to talk all about their projects some of their projects that they've used drones for, and how they use it. What's actually a drone in terms of marine conservation? How it's used? What's the benefits? Some of the legislation stuff that we talk about in terms of how they're managed within like the Marine Mammal Protection Act or even the FAA and all that kind of stuff, like flights and whatnot, and heights of flights and everything. So we're going to talk all about that today. By the way, this is a start of a conversation. So if you want to continue this conversation and you want to answer back, you have questions, concerns, comments, you can do so at the Speak Up for Blue Facebook community group at speakupforblue.com/group. Just use your Facebook account, request to join. I'll let you in. We have over 240 members in the group as of now and as of this recording, and it's fantastic. A lot of people are participating. They're commenting. They're answering. They're replying to comments. It's wonderful. And everybody's inclusive, which is great. This is what I want to build a group that is inclusive of everybody. Everybody's opinion counts. Everybody's respectful to each other, and it's fantastic. So that's what we're going to talk about today. Go to speakupforblue.com/group to join the group to continue this conversation. Let's start the show. If you are sick of hearing of the doom and gloom of the ocean and not knowing what to do, you're in the right place. If you want to meet people working to protect the ocean, then you are in the right place. If you want to find out how you can get involved in protecting the ocean, then you are in the right place. This is the Speak Up for Blue podcast, and I am here to empower you to live for a better ocean. Hey everybody, welcome back to another exciting episode of the Speak Up for Blue podcast. I'm your host, Andrew Lewin, founder of SpeakUpForBlue.com, marine ecologist, and self-proclaimed oceanpreneur. Happy Wednesday, people. It's Interview Wednesdays, and we got a special guest on today, although all our guests are special. David W. Johnston, Dr. David W. Johnston, who's the director of the Marine Robotics and Remote Sensing Group at the Nicholas School of Environment in Beaufort, North Carolina. And this is kind of a special interview. There's a couple of reasons why. First, Monday, Tuesday of this week, I was at Duke University. This wasn't a one-on-one interview. We pre-recorded this on Friday, but I'm at Duke to talk about podcasting for their environmental communications course, which I'm really excited about. Secondly, and I was actually introduced by someone at Duke to David Johnston to get the word out about what they're doing. Secondly, I love technology. I love how technology can be used for marine conservation for good, and I think it's a great way to get people interested in marine conservation. From especially people who the drones are so abundant now. You can buy your own drone at Best Buy for about $1,500. You can buy, I think you can even buy like $200 to $300 little drones to get used to flying them off of Amazon. It's amazing. Drones are available everywhere, and marine conservationists and scientists are using drones to answer critical questions. And we're going to talk about that in this interview. But just like before and after storms, what's the difference? How drones can actually help better than some satellites in terms of especially when it comes to cloud cover. It's just there's so many opportunities with drones, and a lot of these drones that we're talking about can be quite expensive, because they have a payload of extra instruments and whatnot that actually help, like thermal imaging, multispectral imaging, and all that kind of stuff. But we talk about some applications that the Marine Robotics Remote Sensing Group is using, and David Johnston, his lab, is using, just to give you an idea of what can be done with drones. And he's a very busy man now, him and his group, because they're being contracted all over the world to use these drones to answer different conservation questions. They're going to be in Antarctica. I think they're in Antarctica looking at humpback whales. They're looking at gray seal populations, which we've discussed up in the Northeast. abundantly in this podcast. So they're doing some studies there, and they're doing just lots of great things with these drones. And I think it's really important that you guys get a sense of what other applications they're using. I also asked a couple of other applications if it can be used, and David responds to those as well. So it's always great. I just want to say thank David for doing the interview. It's always great to have somebody like him to just give us an update and an idea on the types of technology that we have. Plus, we're both Canadian. We both went to the same undergrad university. He did his master's there, so I think that's kind of cool. We grew up in virtually the same area, southern Ontario in Canada. So it's kind of wonderful to see a Canadian do so much great things, especially with such a wonderful university. So before we get into that, before we get into the interview, just want to let you know we do have a Patreon campaign that's funding right now our mission to get citizen scientists together to basically empower them to make right decisions, or the decisions they want to make, to tag them with or partner them with a citizen science program that can actually work best for them, their lifestyle, and what they want to do, their interests. So what we're trying to do is we're building this community so that we can interact citizen scientists with program managers for citizen science groups, give them more information, allow citizen scientists to get together to discuss what programs they liked, why they liked them, and so forth, what they didn't like, and all that kind of stuff. Improve the programs if we can through feedback and so forth. And it's just it's a free program that I want to build, something that we're going to do in partnership with some other organizations, great organizations out there. Provide some educational resources as well. So it's always a great it's always a great thing to focus on as part of our mission to get more people involved in ocean conservation. So if you go to speakupforblue.com/Patreon, Patreon, you can help fund that, and you become a contributor. Plus, you can help mold what this program is going to look like. So there's blog posts that I post just for contributors, and then you can get the help with that. Plus, I might do some live streams if we get enough. So anyways, thank you very much for listening, and here is David Johnston talking about drones for marine conservation, and I'll talk to you after. Hey, David, welcome to the Speak Up for Blue podcast. Are you ready to dive in and talk about some ocean conservation?
You bet.
I awesome. It's funny. I should have probably prefaced that instead of dive in, we should say, are you ready to fly over and talk about some ocean conservation? Because today we're going to talk all about drones and how drones can play an important role in marine conservation, because that's essentially what a lot of your research is based on. So we're going to get into drones. We're going to get into Duke University and how they're incorporating drones into the research. But first, before we do that, let's get to know you a little bit. And I want you to tell the audience who you are and what you do.
Great. Yeah. So my name's Dave Johnston. I'm a faculty member here at the Duke Marine Lab. And my particular job, I'm an associate professor of the practice of marine conservation and ecology. And so it's kind of a slightly different beast when it comes to professorship. It's a professorship that's focused on being able to translate sort of academic things into real world outputs and outcomes. And so I love this job. It's a great way for me to be able to really feel embedded and in conservation and try and make real world things happen.
Yeah, I mean, that's amazing. Is it what you expected when you first started out your conservation career or your marine science career? Is this the position that you always sought, or did you know about this sort of associate professorship?
Yeah, I was never that good of a planner. But a lot of the things that I grew interested in along the way were applied. I was very interested in theory as well, but I always was much happier when I was working on an applied problem and knew what problem I was trying to solve and working on things that would allow me to actually change something.
And it's interesting that you do that, because a lot of people, when you hear about academics, and you hear mostly, a lot of people when they speak about that, they just think about, oh, well, how can we, it's not necessarily how can we apply the research. It's just how could, a lot of people, I think, just assume that you're just doing research for the sake of doing research. But in this respect, you're doing research that will actually apply to a real world problem, essentially. So, for instance, marine mammal monitoring and what's affecting marine mammal trends. Is that sort of what we like in a top down sort of overview? Is it what you do?
Yeah, absolutely. I mean, I'm trying to take those academic tools and turn them into accessible tools for people, and actually working on projects where we do go out and demonstrate and answer those questions and then transform those things into useful information for policy and natural resource management.
That's awesome. Now, we have a bit of a common background in terms of how we got where we were. Of course, I'm not an associate professor at Duke, but we both grew up or in and around the same area. Why don't you talk about where you grew up and how you ended up being in marine conservation? Because that doesn't always happen from where we're from.
Yeah. So I grew up in Southern Ontario in Canada, and I essentially grew up out in the country and spent almost all of my days in the summertime messing around outside, a lot of the time in the water, and a lot of the time, on family holidays in places around the Great Lakes, where I spent a lot of time in the water and underwater, and have a very strong affinity for that. Fortunately for me, there was a great opportunity to go to the University of Guelph in Ontario, which had an excellent marine science program there, and was able to do my undergraduate and specialized honors in marine biology there, and then I actually stayed on to do my master's in zoology there as well. And so that was really kind of the thing that got me going. The University of Guelph had a great program where we would actually get out to the ocean to a field station on the East Coast.
Huntsman?
Yeah, the Huntsman Marine Science Center, exactly. And so I spent a lot of time out there, and that eventually led into me doing my master's work out in the Bay of Fundy as well, which was a place that became very near and dear to my heart.
Yeah, I can imagine. I mean, it definitely captivates you when you're out there. And St. Andrews, where the Huntsman Marine Center is, it's just absolutely spectacular in the summers. I think it could be a long winter, but definitely in the summer, it's a beautiful place. And I too went to the University of Guelph. I think we just missed each other. You graduated when I was coming in my first year, and I had a great time at Guelph, and the marine program was still just as good when I arrived as when you left, and it's still to this day it's pretty good. Although a lot of the teachers that we've had have gone on and into other things or retired or so forth, but it's still a pretty good marine program. So then you ended up after your master's of zoology, you ended up at Duke University to do your PhD. Is that correct?
Yeah, I did. So I ended up coming down here and again focused on some work out in the Bay of Fundy. Some integrative work, and really where I got my first really, sort of opportunity to start integrating new technology into my science. And so my dissertation was kind of a really cool mashup of wildlife telemetry, radar sat, satellite imaging, and more common methods like distance sampling and photo ID and focal follow work that I got to kind of bash all together into a really integrative look at an island wake in the Bay of Fundy.
That's amazing. Now, when you were going through that, when you were going through your PhD, how did you figure out all this technology? I'm assuming have you always been sort of tech savvy that way, or is this something you just learned on the way, or took some courses at Duke or other places?
Yeah, mostly self-taught. I've always been really interested in networking and computational approaches to things and robotic type things. And so I've definitely been, sort of labeled as an early adopter of technology. And in some cases that's really great. In some cases it can be disastrous, but I've been able to kind of walk through that minefield pretty well.
Yeah. Oh, I can imagine. I went to, when I did my master's out at Acadia University out east near the Bay of Fundy, I did a GIS course for 8 months before I started my master's, and I was kind of a guinea pig before that program. And then they actually built, my supervisor John Roth, who you had as a teacher in your undergrad, helped build a program with a partnership between the school of the COGS, which is the Center of Geographic Science at the college there, and Acadia University. So now I was the guinea pig going through that. So I had 8 months to learn GIS and programming and automating and whatnot. So I can just imagine with the teacher-led courses, I can just imagine how time consuming it must have been and a little frustrating to work through those challenges to get to remote sensing applications and telemetry and so forth. but it's kind of led you down the right path in terms of where you ended up. And did you stay at Duke for a while, or did you go somewhere else in between?
Yeah, after I finished my PhD, I went and did a postdoc at the Monterey Bay Aquarium Research Institute in Moss Landing and Bari.
Okay. Okay.
Spent a year there, and then actually ended up working for NOAA in Hawaii for about 4 years, running their cetacean research program as they were developing that center. And so it was kind of a nice trip west for us. And along the way, I'd met my future wife during my PhD. Along the way, we spent some time in Vancouver. We also, got married and had our first baby in Hawaii, and then eventually fetched up back here in North Carolina at the Duke Marine Lab.
So that's kind of nice. You kind of spread your wings a bit and found some new territory and some new different species of cetaceans, I guess, to study and so forth. Was your PhD on cetaceans as well?
It was. My PhD was working on mostly on harbor porpoises, but also on minke whales and fin whales. And it was really nice to go to other places. And as you know, from the Bay of Fundy, this really incredibly dynamic place with these incredible tides. It's a very different environment in the Pacific. It's much more laconic, so slow moving compared to the dynamics of the East Coast of North America, that it's really cool to be able to see across these different biomes and physical sort of areas. So it was really great to be able to think about things at different scales and
for sure
things. Yeah.
Yeah, absolutely. And now you're working with drones. I guess all that remote sensing paid off, because now you're working with drones. Now, we hear the word drones all the time. A lot when we first started hearing of drones, outside of research, a lot of times it was military, and they usually had a negative connotation to it. But now they seem to be using drones. A lot of people are buying their own drone from like Best Buy and whatnot, and have it as hobbies. Real estate agents are using it to, record what a property would look like for selling. And now researchers are using drones, incorporating in their research. So how long have you been using drones in your research? And first, I guess maybe define, what would you define a drone as in terms of what your research capabilities are? Yeah,
so for us, we use drones, and drones is probably the easiest way to refer to it because people understand that. That word tends to have some negative connotations, and so when we think of it in scientific terms, we often would refer to them as UAVs. So unmanned aerial vehicles, or if you want to be less gendered, unoccupied aerial vehicles. And when you think about that particular, the actual aircraft that's flying around, it also has a bunch of other things that are associated with it: a sensor package, and also a ground control station or controller. And we think of that as an aircraft system, so an unmanned or unoccupied aircraft system. And so those are the acronyms that you'll see in the scientific literature, UAV, UAS. But when we're talking about stuff like this, we talk about drones.
Okay. And so now, there's a lot of new concerns about using drones for research that seem to come to light. And I don't know if there's still a concern right now, but especially around marine mammals. Because of the Marine Mammal Protection Act in the U.S., I know there was a bit of a concern of using drones either for research or for just photography, which a lot of people have been using it. But under the Marine Mammal Protection Act, you cannot harass or disturb in any kind of way marine mammals. So how can you use a drone so that you still abide by the Marine Mammal Protection Act, but still doing research with them? Do you have to deal with the body behind the Marine Mammal Protection Act to make sure that you're doing it properly?
Yeah, so we get permits, and so there's a very straightforward process to be able to apply for a permit. And depending on the status of the animals that you might be wanting to work on, it takes anywhere from 6 months to maybe a bit over a year, usually, to get that permit. And so and then that essentially allows you to disturb animals, in the process of you doing your research.
Right.
I have to be honest with you. I don't think that we really disturb many animals when we do our work with drones. And
right.
I think it's a great thing. And I think if the easiest way to probably think about it is, what kind of methods are we replacing by using the drones? And so,
Hmm.
so for a lot of the missions, what we're trying to do is to get close to take pictures of them or to look at their behavior
Hmm.
and, or to count them. And, the alternative methods, tend to, provide for greater disturbance anyways. So you imagine you might have to go to a colony and walk around to be able to count animals or
Hmm.
make behavioral observations,
Hmm.
which can be quite disturbing. In some cases, you want to fly over them with big occupied aircraft that are loud.
Yeah.
Uh, and and then on the water, a lot of time you have to approach animals in boats and get quite close to do some things. And in all these cases, the drones, will probably end up being best practices, right? Where we can
Hmm.
actually do this work with the least amount of disturbance towards those animals.
Yeah, no, absolutely. I completely agree with you. I wanted to make sure you answered that question just because there were a couple of blog posts that I've seen that it, a lot of people were frustrated at that it was impeding. The people were the concerns. I think it was at the beginning when drones were first being used for research, where the Marine Mammal Protection Act people didn't really know how to interpret it and if there was going to be any disturbances. But I think you laid it out perfectly. I really don't think there's any disturbance. I think it's actually better. You think about using less gas, it's less expensive, less per person power. I just think it's a great opportunity
Yeah,
to use drones and
yeah,
definitely a lot less invasive in terms of what you guys do and when and the alternatives that have been used in the past. So I think
yeah.
that's a great way to put it. So thank you for for answering that question.
Oh, my pleasure. And those people that are working on those permits, they have this kind of unenviable position because there's new things that are happening all the time, and
Hmm.
they're responsible for trying to figure out, what
Yeah,
is disturbance for those animals. And so it's a regulatory inefficiency that's can be frustrating for people at times, but it's probably necessary to some extent so that we kind of do maintain our best practices.
for sure.
So yeah, but it's
Yeah.
yeah, it's a process and it takes time, and I think we're getting through it quite well now.
Well, and yeah, and I find too. I think if once you work with those permits and you do it properly and you follow what they want, I think the permitting is going to get easier and easier as you build that relationship. That you've done good work in the past. You've shown any kind of best practice that you can to not disturb the animals, because your research is to make sure you're protecting the animals and understanding them, so you're not going to disturb them. It's probably not good for your actual studies as well for to do that kind of stuff. But
Yeah, no,
um,
exactly. It's bad for the animals and bad
yeah,
for the so.
yeah, exactly. Now let's get into what types of questions, conservation questions, we can answer using drones, because I think that's always a question. It's a question that I've always had, and a friend of mine here, like I was mentioning before we started recording, a friend of mine here has a suite of drones that are not your Best Buy type drones. They're more expensive. They also have thermal imaging. I think you have that as well. We discussed, and they have other different tools to take different pictures and analysis of sort of thermal discharges and whatnot. But for marine conservation, what questions can we answer with these drones? I know there's probably a breadth of it, but just even like the general questions, and you, by all means, say some examples of what type of projects you're doing. We can get into those as well.
Yeah, for sure. So I think probably the best way to think about it is kind of what the technology provides that we haven't had before. And
Hmm.
so, if you were sitting down here at the Duke Marine Lab, you'd be looking across the tidal creek at the Rachel Carson Estuarine Reserve. And, we have a lot of projects that go on there. The research reserve is essentially set aside for us to be able to understand these kind of estuarine systems better. And a lot of the time we have students or faculty that are working over there, and they're making very high resolution measurements. So you can imagine, in a marine ecology sense, putting down a quadrat and
Hmm.
counting the number of plant stems in that particular thing, or the number of sand dollars.
Right.
Or maybe it's a laser, laser line scan or something that's, making incredibly high resolution measurements of the beach because you're interested in what a storm might have done or
Hmm.
might to that place. So that's kind of the baseline for how most people go about doing kind of marine ecological work, and then the only next step up, up until the advent of affordable and sort of science grade drones, was occupied aircraft, and then satellites.
Right.
So while satellites are great, and in fact can be incredibly high resolution now, sub-meter data around the world almost every day. They're affected by atmospheric, so you have to worry about clouds. There's a lot of issues. They're difficult to task.
Mm-hmm.
And the same thing for occupied aircraft. It's actually logistically challenging to spin up a Twin Otter flight, getting the kind of gear that you need in it. You will have to have at least 3 people in the aircraft, probably more. And then again, you're also suffer from atmospherics. So if you can't fly low enough, you have to deal with clouds. And in a place like where we live here, in the summertime, humidity actually has a really big effect on what you can do image-wise.
Mm-hmm.
And so, our drones fit right in the middle there, right? They allow us to be able to make incredibly high resolution measurements, sometimes at the same scale of what you might be sampling on the ground with a quadrat.
Wow.
But they don't suffer from having to deal with clouds.
Right.
And it's essentially an on-demand technology. We can go, as long as it's not pouring rain or blowing 30 knots, we can actually go and fly and collect data. And so, the advent of incredibly high resolution on-demand remote sensing is something that we've never had before. And you could now start thinking about the range of different science applications that you could apply that capability to. You might be interested in the effects of a hurricane on a beach. Well, you can fly right before the hurricane and you can fly right after the hurricane.
That's it. You read my mind. That's exactly what I was thinking about. I was like, on demand.
So we've done that. We've done that. We're able to actually, and that helps us move away from just detecting change to actually understanding process, right? So we can reduce the number of contributing factors in that environment and really look at what that storm did to that place. If we want to,
just to interrupt it, just because a question that just popped up in my head, I'm thinking like where you are, there's an estuary and whatnot. Is there any kind of penetration into the water in terms of seeing into the water that you can do, or is it a lot of it's just looking at land use changes around and differences in, say, like a beach or maybe a seagrass or salt marsh area around your area? Like, how much is there penetration into the water, and how clear is it?
Yeah, there is. And in fact, when we got started, a huge amount of our research was really just focused in on trying to understand what our detection capabilities were.
Okay.
And so, a lot of the first work that we did in the U.S. was here, just right, at the Marine Lab, was focusing in on, how well can we see a shark at different depths across a different range of tidal conditions or turbidities.
Right.
And so to do that, we actually, we worked with some folks over at the UNC lab, and we built shark decoys, and we put them out, and we flew over them under these conditions to look at what their detection probabilities were. The same thing with seabirds and sea turtles. We're able to use these stand-ins, right? So not having to actually work with live animals to be able to build our initial sort of understanding of detection probabilities before we would go and try and work operationally with wildlife.
That's amazing. That is so cool. Do you get a lot of requests for collaboration to do research because of the instrumentation that you have and the expertise that you've developed with this instrumentation as well?
Yeah, absolutely. And so one of our sort of goals with the center is to do exactly that. We about 2 years ago, we put in a proposal to an NSF program that essentially allows or provides money for advancing facilities. And so this particular program would, the proposal was essentially to develop a center that would have state-of-the-art teaching space, state-of-the-art engineering space, a larger fleet of aircraft with different sensors to be able to do broader things, and a better computational infrastructure to deal with the data. And the idea was that we would be able to support other research projects, including NSF projects that people are interested in doing. And so, we're kind of open for business in that sense. So we actually do a lot of research support. And some of it's not necessarily always even marine. This past summer, we had a team working with the archaeologists from Duke, working in Volci, Italy, and in Agrigento in Sicily, looking at these incredible Etruscan and Greco-Roman archaeological sites. We had a team working with another group in Scotland to work on dolphins just recently. And in fact, right now, I have a team in California that's working on blue whales, and that's in support of another NSF project. And so we were able to plug in and actually fulfill some of those things so that people can get their work done without having to spin up their own drone program.
That's amazing. I mean, I guess that would be the major concern for other researchers, as well as other, I guess, say, like when we talk about marine conservation on the podcast all the time, it's not just for researchers or academics, but it's also for sort of local communities and fishing communities and so forth. I guess the major concern is how expensive these drones are to do the specific tasks you want to do. And I've seen a lot of people, a lot of researchers really experiment with I guess what you would call a quote unquote, the run of the mill, easy to purchase drones. And I forget the name of the drones, but you can get them at Best Buy and so forth with, you can mount a GoPro, or they have a high resolution camera on there, and you can take some pretty decent pictures. For those run of the mill sort of Best Buy type drones, what are the capabilities of those, and what can you really do with those types of drones?
Yeah, it's remarkable, actually, the kinds of things you can do with commercial drones that are available. If you roll on out to Best Buy and buy a DJI Phantom or a Mavic or something, or you buy a 3DR Solo, or any of those other smaller commercial drones. They have good cameras, or you could put a GoPro on them, and they can be very useful for some things.
Right.
We use them in some cases for just basic scouting, to be able to provide contextual video for things, to be able to collect behavioral video of things. There are some things that you can do with that. The cameras are often actually really good and useful for a range of different things. Often the flight times are quite limited, and in some cases they just can't actually achieve some of the mission objectives that we have. For example, a lot of those drones have issues. These sort of smaller commercial drones have issues launching from a boat, because they can't calibrate, and because the boat is moving, they don't have a good reference, and so there are some things that you just won't be able to do with some of those things, not necessarily because the camera is no good or because the sensor's not what you want, but because the actual aircraft wasn't designed to be able to do those things. So, but yeah, I mean, there's a lot of really great things you can do with some of those affordable aircraft.
That's amazing. That's awesome. And so let's talk about some of the projects that you guys are doing. Let's talk maybe like one or two of the projects, and then we can maybe ask a couple questions on each and sort of what the results have been so far, if there's some that are ongoing. So name anyone you want that you want to discuss that you like.
Yeah, sure. So, we work across a big range of different projects, from marine archaeology all the way through population assessment stuff. And so, one of the things that we've been working on is trying to get a better handle on what's happening with gray seal populations in the Northeast. It's a very interesting conservation situation with this species that was depleted and is now recovered. And we're trying to understand a little bit more about their role in ecosystems. And to do that, you have to actually know how many there are. And so we've been working with drones to try and essentially develop population assessment techniques that make things simpler and maybe provide better data. The other nice thing that I would add to it too is that we can generate great data and we can maybe reduce the costs some, but the other thing that we can do is reduce the amount of time that people are in the air over the water in aircraft. Right. And so there's a safety factor as well that I think we enhance. Yeah. But in this case, we've been flying in various places, looking at how we can use standard RGB imagery and thermal imagery to try and understand the population size densities of pinnipeds in their breeding habitats. And so, pinnipeds, they're mammals. and so they're often at an ambient or at a temperature above ambient,
Hmm.
and so they're easy to detect in a thermal image. And those types of techniques, it's really great to be able to go out and collect all this imagery and make it safe and cheap and everything, but it returns a huge amount of data back to us. And so not only are we interested in trying to figure out which sensors are appropriate for doing this, but having streamlined workflows that allow us to make use of this huge amount of data is something that we need to develop in parallel. So as we've been working on best practices for being able to fly thermal flights for things like gray seals, we've also been developing computer vision models that are accessible to people so that they can take their imagery and count seals in a much faster way, and also in a way that reduces personal biases between the number of analysts that might look at a photo and count. The computer does it the same way every time. So
Yeah, well, especially with citizen science projects that have been developed too, where you might get some bias in terms of counting pinnipeds in certain areas as well, right?
yeah, so there's a lot of that's one of the areas that we've been working on. We're hoping to get out to a few other places and do that, and including working down in the Antarctic as well in the next few years. So that's one project that's been really cool. At the other end of the spectrum, we've been working with the Maryland Department of Natural Resources and NOAA to work on a marine archaeological project in a place called Mallows Bay, which is just on the Potomac, right across from Quantico, essentially.
Mm-hmm.
And in that place, there's about 200 Liberty ships. They're ships that were used in the First World War, and were eventually scuttled in this bay. You can kind of think about it, wow, like that might be a big ecological disaster. But they were mostly wood. The ships were wood with some concrete in their keels and some metal to kind of tie everything together.
Right.
But what these wrecks have really done is kind of structured the subsurface habitat for that place, and so we're able to actually use the drones to be able to fly over, geolocate these wrecks, and essentially build a baseline so that we understand where they are, and especially in the face of things like sea level rise, that kind of stuff, where they may disappear.
Right. Right.
Which is really cool, right? I mean, it's this wonderful intersection. You look at the imagery from these places. These shipwrecks are actually turning into islands. They have accumulated so much material in them that they have soil now, and they're growing trees, and they're supporting populations of insects and birds, and it's this wonderful connection between maritime heritage and environmental science in this
Right.
world.
Are you able to take the like bathymetry and sort of water levels in certain areas, like in shallow areas?
In shallow water, yeah, we can if the water's very clear,
Right.
but it's never as accurate as what you're going to get from a sonar technique. And there are some packages that help to deal with refraction, and then there are some people, some really super smart people, that are working on a fluid lensing technique that actually sort of computes out the parts of the image that are out of focus and are dark, and can generate really accurate bathymetric maps from video data. But for the most part, it's challenging to do that unless the water is really clear.
Yeah.
You really need to move back to surface methods where you would use a sonar.
Yeah. What about I know there's a aquatic lidar now, right? There's lidar for land, but then now there's like sort of like a water lidar which can take bathymetry.
Mm-hmm.
And I know at one point somebody had told me that they haven't figured out the capabilities to fit an aquatic lidar and make it function like it does. Usually it's an aerial survey on a drone. Has that been able to be done yet, or is that close? Because I think that would be so handy in terms of getting like local area.
Yeah, so there are definitely small lidars that you can put on drones now,
Mm-hmm.
that are really useful, and even with the lidar in these places where you have a lot of silt and stuff, you're going to have a problem because the laser is just not going to penetrate down deep.
Right. Gotcha.
Yeah, so it's going to be an ongoing challenge. But the nice thing about the LiDAR packages that we have for UAVs is that they allow us to kind of see through the foliage
Mm.
for doing coastal surveys. When we build our surface models, we do that with a structure from motion approach, which uses kind of massive photogrammetry from all the photos that are collected.
Right.
But it focuses on the canopy, right? And lidars are really good at penetrating that canopy, and so we're able to use a lidar to generate a surface model for an island that would allow us to see that would represent what's happening underneath the canopy, which can be very, very useful for some things.
That's
So
fantastic. That's amazing. That's amazing. So let's do one more project because I know you have to get going. But I'd love to hear one more project that you're doing.
yeah, so one of the projects that I'm really excited about is this work that we're doing down in the Antarctic, using UAVs to be able to study the foraging behavior and body condition of big whales, in this
Interesting.
case humpback whales, and so we were able to fly our drones over these animals and record video of these really intricate behaviors, bubble net feeding behaviors, and other sort of coordinated behavioral things. Having this top-down view provides so much more of,
Mm-hmm.
and also to be able to get images of them so that we can measure them. So it's pretty hard to actually size up a whale.
Mm-hmm.
In the whaling days, you're able to actually kill an animal and you can measure it all you want.
Right.
Um, but these are tools that allow us to make measurements of animals without having to do that.
Which
And
is
we can
awesome.
look at how animals, how their body condition changes through a season. We can understand if we follow individual animals through time, we can understand how their body condition might change as things in their life change. And
Mm-hmm.
so it's a very powerful tool for us to be able to understand how humpback whales, say on the Antarctic Peninsula, are responding to this very rapid warming that we've seen,
Yep.
and, and also the recovery of other krill predators in that place. Many of the pinnipeds have been released from human pressure as well, and so it really helps us try and see how these whales are kind of fitting into this ecosystem there.
Of course. Yeah. How difficult is it to fly in the Antarctic? It's got to be like just with the different weather patterns. Do you have to be careful in terms of what type of drone you use?
You do have to have equipment that's capable of dealing with cold,
Mm-hmm.
and a lot of it is about battery management, and actually a lot of it really comes down to good flight planning and
Mm-hmm.
experience. But the aircraft that we use, for example, are pretty heavy lift multicopters that carry a multi imaging payload that includes 4K video, a really high resolution still camera, thermal video, and a laser altimeter. And that laser altimeter is actually a key component because when you know how high off the water you are,
Mm-hmm.
it allows you to scale your photos. You know a lot about your camera, your sensor size, your focal length of the camera. And when you know how high that camera is above the surface, you can actually use that to scale those pictures so that every pixel is a real world unit. And
Yeah.
that allows us to make incredibly accurate measurements of these animals
Yeah.
as they're doing stuff, or measurements of their habitats, or
Mm-hmm.
even their bubble nets, the things that they're actually producing, we can measure now.
That's amazing. That's so cool. I got two more quick questions in terms of what questions that I think that could be applied using drones. You've heard probably in the news up in Canada anyway, about the right whales that have been dying in the Gulf of St. Lawrence. I'm always in the thinking that the best way to look at what's happening with these whales is to send up drones to try and track where these whales are going in the Gulf of St. Lawrence, because apparently they've come back, and what's happening in terms of why they're getting hit by ships or getting entangled in fishing nets and so forth. Can you use drones to do such things, like to monitor sort of right whale populations because they're an endangered species and they're important to find out where they're going and why they're dying?
Yeah, I think that's kind of very similar to our population questions about seals. How would you execute a survey for animals in that place with a UAV instead of putting a bunch of people in an airplane? And,
Mm-hmm.
and the
Mm-hmm.
truth is that technology all exists. It would not be difficult to execute that at all. And there are drones that are available now that can fly for 8 to 10 hours, that can cover
Mm-hmm.
huge areas. The biggest sort of challenges that we have in those areas are regulatory. So, what you're talking about requires beyond line of sight. It requires, a lot of sort of dealing with regulations so that you can achieve the mission without breaking the law. And so, but those things are totally navigable. And it took us a while to navigate the system to be able to fly here in the national airspace here in the U.S. because
right.
There was no real process for that. There is now.
Yeah.
So a lot of it is really just doing that kind of basic work to be able to deal with the regulatory requirements, comply with those things, and have the right equipment to be able to go and do it. And you would be able a system that would be able to, allow people to monitor in real time those surveys if they wanted to, as well as collect and archive imagery. And it would allow you to kind of focus in on animals as well. And with right whales, you can identify individuals pretty easily. So if you were interested in particular animals or animals that were particularly at risk, you'd be able to generate that information pretty quickly. So,
awesome.
So absolutely, that's a totally feasible thing. The technology exists. It's really just, deciding when you really need to move to the unoccupied sort of approach.
Yeah.
And how to do that in a way that makes it safe and legal.
Of course, yeah. And one last question. You probably heard of, or you may have even seen, the movie Chasing Corals. It came out on Netflix about a month ago. It's made some big headlines in terms of showing how coral reefs have been bleaching over the past 3 years in different areas of the world. I see a drone application doing this, especially in local areas, to monitor bleaching of coral reefs in very shallow areas where there's clear water, which they tend to occupy. Do you see an application for that for monitoring coral reefs and finding out if they're bleached or not in terms of just color recognition?
Yeah, absolutely. And in fact, there are groups around the world that are doing that now, using drones to be able to look at coral health in various places. And yeah, you talked a little bit about color there. I think what's really nice about where we're going with drones is that a lot of this information can start to be processed, on the aircraft, as we're moving along. It's nice to be able to think about how we could have the aircraft a little bit smarter, do some processing on board through computer vision techniques, and allow us to take advantage of that computer in the sky to maybe do better flights. So in this case, if you're flying, over an extended part of a reef and you notice that the color changes and the computer says, okay, I've got a bleaching event that occurs in this place. I'm going to drop down to a lower level. I'm going to map it out in greater detail. There's a whole bunch of things that are coming, right? That because our computers are so small and such low power, that we can turn those robots into much smarter things. We don't get humans out of the loop, but we let them help us. Things that we need to do, and that could be that could be done in a bunch of different ways. It might be for finding stranded whales, or it could be for illegal fishing, or any number of conservation missions where we can make use of this technology to do good.
It's amazing. This gets me so excited. I love this kind of stuff. David, I just want to thank you. I know you have to go teach a class, so I want to say thank you very much. I really appreciate you coming on and talking about drones and sort of introducing us to this technology and the applications that we can use it for in marine conservation. And I think what you guys are doing with your groups in the Marine Robotics and Remote Sensing group at the Nicholas School of Environment is just is fantastic. What you're doing, your team is amazing. The work that you're doing just sounds brilliant. And what we'll do is in the show notes, we'll put all the links to the pages that you have more information on other projects that you're doing and all the people that are involved and the students that are involved. And I just want to say thank you very much. We really appreciate you coming down and love your work.
Well, thanks. My pleasure. I've really enjoyed it. So yeah, please just let me know if you need anything else. And I hope you have a great rest of the day.
Absolutely. Just stay on the line. I'm just going to end it, but thank you very much.
All right.
So that was Dr. David Johnston. Thank you very much, David, for coming on. I hope you guys enjoyed the interview as much as I did conducting it. I love drones, and I love the fact that we can use more drones. And there are companies that are popping up that have really great drone instrumentation that can answer a lot of questions. And I think one of my missions is to continue that and ensure that these drone companies are able to serve the marine conservation community in a way that people can answer specific questions that they want to answer. So that's going to be great. The work that the Marine Robotics and Remote Sensing Group that they do is amazing. I'm going to post their links in the show notes so you can take a look. But David, thank you very much for doing the interview, and everybody else, thank you very much for listening. If you want to continue this conversation, have any questions, concerns, comments on this interview or any other part of the podcast, you can go to speakupforblue.com/group, and you can post your questions, comments, concerns in there. Share some stories, participate, answer some other comments that are on there and posts. You go to speakupforblue.com/group, use your Facebook account, join the group. It's awesome. If you want to contribute to our Citizen Scientist program, you can do so. speakupforblue.com/Patreon, Patreon. And that is your episode for today. Thank you very much for listening. You have been listening to the Speak Up for Blue podcast. I am your host, Andrew Lewin. Happy Wednesday and happy conservation.